And hey, how's it going on, guys? My name is BJ and I am here for another video tutorial episode. So our topic for today is function and their graph. So first, what is function? A function is a relationship or expression involving one or more variables. So I have an example of function here. Example of function bx plus c. So this equation is one or more variable because bx is a variable plus c is a variable too. So bx plus c is two variables. So this is function. So let's move on to another topic.
Functions can be defined in other terms of functions. Example, the function defined by f of x is equal to x squared plus 8 is the sum of g of x is equals to x squared and h of x is equals to 8x. So, if you're given any two functions, g and h, we can simply define it as the four new terms of functions: g plus h, g minus h, g times h, and g over h. So, here is an example of operation on functions. The given is g of x is equals to x squared minus 1 and h of x is equals to x plus 1. Find g plus h. We're going to substitute the values on the solution. So the solution is g plus h of x is equals to g of x plus h of x. So x squared minus 1 plus x plus 1 is equals to x squared plus x. Now we're going to find the difference of the function. Find g minus h. The solution is g minus h of x is equals to g of x minus h of x. Substitute again the values. So x squared minus 1 minus x plus 1. Distribute the signs. X squared minus 1 minus x minus 1. And the answer is x squared minus x minus 2. Next is looking for the product of the functions. Find g times h. So the solution is g times h of x is equals to g of x times h of x. Substitute again the values. X squared minus 1 times the quantity of x plus 1. X squared plus x equals to x cubed. X squared times 1 is equals to x squared. Then negative 1 times x, negative x, and negative 1 times 1 is negative 1. So the answer is x cubed plus x squared minus x minus 1. Last on the operations and functions is looking for the quotient of the functions. Same given, find g divided by h. So g divided by h of x is equals to g of x divided by h of x. Substitute again the values. So x squared minus 1 divided by x plus 1. We're going to factor out the x squared minus 1. So it is x plus 1 and x minus 1 divided by x plus 1. Then we're going to cancel x minus 1 and x plus 1. So the answer is x plus 1.
So today, I will show you how to use rational function in real application. Our problem is, we know high school student can fit 1,000 feet in 8 minutes, while 1/3 quick high school student can fit only 150 in 10 minutes. If they work together, how many tweets can two schools send together in 5 minutes? So we're using this formula, 1,000 for bring up high school student tweets over 8 minutes plus the 950 tweets of 3 high school students over 10 minutes is equals to x over 5. X is for how many trips can 2 schools send together? Over 5 for 5 minutes. We will simplify this first. 1,000 over 8 is equals to 125 plus 950 over 10 is equals to 95 equals to x over 5. Simplify again. 125 plus 95 is 220 equals x over 5. So we will multiply 5 by 5 both sides. So x is equals to 1,100. So the two schools can send tweets together in 5 minutes is 1,100. Thank you. So here, our next topic is solving rational equation. Solving rational example. Our example here is 6 over x squared minus 5 over x is equal to 1. So, what we're gonna do here first is to get the LCM or the least common multiple. Our least common multiple here is x squared. So now we get the least common multiple. We will multiply x squared by both sides. So 6 over x squared minus 5x equals 1. So multiply both sides by x squared. Then what we're gonna happen here is there will be remain here is 6 minus 5x. So here is equals to x squared. So now we get this equation. As you can see, this is a quadratic equation. So what we're gonna do here is let the left side is 0. So we will transfer these two variables to the right side. So x squared plus 5x minus 6. So we have a quadratic equation. So we're going to do here is we're going to factor this out. So our factor is x plus 6 1 and x minus 1. So this equation let us make this x plus is equals to 0. So x plus x is equal to 0. So x is equals to negative 6. Then another x is x minus 1. So x is equals to 1. Thank you. Then, our next topic is solving rational inequalities. We have example here, x minus 4 is over x plus 2 less than 0. So, what are we gonna need to do is let the top and both side make them 0. So, if we substitute this x as 4, positive 4, 4 minus 4, 0. So, we have our top side 4. So, x is equals to 4. So, next, in both sides, if I substitute this x into negative 2, I will get 0, 2. So, negative 2 plus 2 is equals to 0. So, I got the next x is negative 2. So now, I have this top and both side 4 and negative 2. I will make a number line. Number line like this. So, now I got this number line, negative 2 and this is the positive 4. So next, I will need to know which part of these are shaded. So what do I need to know is what I need to put number here. What I meant numbers are here. So you have here. So if we use -5 here, so let's start here on the right side. It's +5 because 4 is 5 greater than 4. So let me say 5. We're using 5. So substituting this excess. So 5 minus 4 is positive. 5 plus 2 is positive. So positive divided by positive is positive. So this is shaded. Then next, 0. If we got 0 here, negative, 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 and here is positive. So negative over positive is negative. So this is not shaded. And -3 here. We're getting here a negative sign, and here again is negative solution. Negative solution, negative solution. Negative divided by negative is equals to positive. So this is shaded too. So as you can see here, this is what will be. This is what will be. So our solution here is -infinity and -2 union to 4 to +infinity. Thank you.
So we will find the domain, range, X-intercept, and Y-intercept of a rational function. So first, let's define domain. Domain is a set of all values that the variable x will take. Next is the range. Range is a set of all values that f of x will take. Next is the X-intercept, which is the values of x which make the function 0. And Y-intercept is a function value when x is equal to 0. So given the rational function f of x is equal to x plus 1 all over x minus 4. So we will find the domain, range, the X-intercept, and Y-intercept. So first is the domain. In the domain, we will only focus on the denominator of the rational function, which is the x minus 4. And we will equate x minus 4 to 0. We equate x minus 4 to 0 because we are finding the values that will make the denominator 0. So our domain will be x minus 4 is equals to 0 transpose as x is equals to 4. So our domain will be a set of all real numbers such that x is not equal. Next is the range. Remember that the range of a rational function is equal to the domain of its inverse. And if it doesn't work, the best way to find the range is to make a graph. So here we will use the domain of its inverse. So given the rational function f of x is equal to x plus 1 over x minus 4, y is equals to x plus 1, x minus 4, then x is equals to y plus 1 all over y minus 4. So we will use the equation xy minus 4x is equal to y plus 1. So you transpose xy minus y is equal to 4x plus 1. So we will factor xy minus y. So y times the quantity x minus 1 is equal to 4x plus 1. To get the y value, we will divide both sides by x minus 1. So our range will be y is equal to 4x plus 1 over x minus 1. So our range will be all set of real numbers if not equal to y is equal to 1. Next is the x-intercept. In the x-intercept, we will use the numerator of the rational function and we will equate it to 0. Given the numerator x plus 1, equate it to 0, we will get x-intercept x is equal to negative 1. To get the y-intercept, we will substitute this 0 to the variables of x for the numerator and x in the denominator. So 0 plus 1 all over 0 minus 4 is equal to y is equal to 1 for negative 4. Getting the horizontal asymptote. In getting the horizontal asymptote, we have 3 conditions. First condition is that if the largest degree of the denominator is greater than the largest degree of the numerator, then our horizontal asymptote will be y is equal to 0. Next condition, if the largest degree of the numerator is greater than the largest degree of the denominator, then we doesn't have a horizontal asymptote. Our third condition is that if the largest degree of the denominator is the same to the largest degree of our denominator, then we will divide the coefficients, the leading coefficients of the numerator and the denominator. So our horizontal asymptote now will be 2. The given rational function that we're solving is f of x is equal to x plus 1 all over x minus 4. So our horizontal asymptote will be, since they both have a degree of 1, and we assume that x always have 1 decided, but we always disregard third one must be redundant. So x divided by x. So our horizontal asymptote now will be y is equal to 1. Next, getting the vertical asymptote. Getting the vertical asymptote is the same with getting the domain. We just have to equate our denominator into 0. So x minus 4 equals 0, transpose plus 4. So our vertical asymptote will be x is equal to 4. Problem solving involving rational equation. Given the problem, Ethan takes 15 minutes and Jake takes 60 minutes for the newspaper distribution in Makati. How long it will take for both of them working together? So, let T be the time Ethan and Jake working time. So we will use the equation. For Ethan, 1 over 15 E plus 1 over 16 E is equal to 1. Divide both sides by 16 as 8. So it will be cancelled. This one, it will be cancelled too. So it will be 4t plus t equals 16. Combined like terms, 5t equals 16. Now divide both sides by 5. So our time now will be 12 minutes. So the time that Ethan and Jake will be 12 minutes. Problem solving involving rational inequalities. Given the problem, Sam and Alex play in the same soccer team. Last game, Alex scored 3 more goals than Sam, but together, we scored less than 9 goals. What are the possible number of goals Alex scored? So let S be goals Sam scored and let A be goals Alex scored. So our inequality will be S plus A less than 9. S, let A be S plus 3 less than 9. Simplify, combine like terms, 2s plus 3 is less than 9. Now transpose positive 3. So 2s less than 6. Divide 2s and 6 by 2. That's 4. S is less than 3. So, the score of Sam will be 0, 1, or